Hello and welcome to The Explainer. Today, we are diving into the fascinating, super fast-moving world of artificial intelligence in video games. Now, this is tech that's been quietly shaping our virtual worlds for decades, but right now, it's about to completely change how we play. So, let's get into it. I want you to think back for a second. Way before AI was in our pockets, in our cars, and all over the news. For most of us, AI was really just the stuff of science fiction, this futuristic idea about thinking machines.
And a perfect example of that was the 1983 movie War Games. You might remember it. It's where this supercomputer figures out that when it comes to nuclear war, the only winning move is not to play at all. It was this thrilling, kind of scary look at what a game-playing AI could actually be.
Okay, so while War Games was obviously fiction, that core idea of AI inside a game has been very, very real for a long time. It's usually this invisible engine, just humming along in the background, making our favorite games tick.
So let's start there, with the AI that's already here. This is the foundational stuff that gamers have been bumping up against for years, a lot of the time without even realizing it.
The truth is, AI is already doing a ton of the heavy lifting in the games we play every single day. It's the brain behind the non-player characters you talk to, it's what's adjusting the difficulty on the fly, and it can even be the architect that builds entire worlds from scratch. And behind the scenes, it's a massive tool for developers and for boosting graphics with neural net processing. That's the magic that upscales images so you get those buttery smooth frame rates. Really, this stuff is the backbone of modern gaming.
Let's dig into one of those. Dynamic difficulty is basically the game's way of asking, hey, are you having fun? In a game like Left 4 Dead, there's this AI director that's literally watching you play. If you and your team are just crushing it, it might throw a massive horde of zombies at you. If you're getting your butt kicked, it might ease up a bit. It's all about keeping you in that perfect zone between being bored and being totally overwhelmed.
And that leads to another huge job for AI, procedural content generation. Think about it. How could a small team of developers possibly create a game with billions of unique planets? The short answer is, they can't. Not by hand, anyway. So in a game like No Man's Sky, AI algorithms do the work. They generate entire worlds, complete with their own plants, animals, and terrain. And the result is a universe so big it's practically impossible to see everything.
But all of that was yesterday's AI. Now the tech is seriously leveling up. These new advancements are moving out of the background, and they're starting to change the fundamental experience of what it even means to play a game.
This brings up a fantastic question from Julian Toglias, an expert over at NYU's Game Innovation Lab. Does every single game need some kind of super genius AI? And his answer is no, not really. In a classic fast-paced shooter like Doom, the fun is all about pure reaction, pure skill. You don't need a demon that's having an existential crisis. You just need a demon that runs at you so you can shoot it.
So it's kind of a tale of two genres, right? In a shooter, the AI's job is often to be a predictable but fun obstacle. But in a big, sprawling role-playing game, that's where a sophisticated AI can create a world that feels truly alive, with characters that react in unscripted, believable ways. And that is where this next generation of AI is starting to shine.
And this isn't just theory. We're already seeing it in action. The game developer, Ubisoft, has a prototype that uses a large language model, the same kind of tech behind ChatGPT, to let you have actual unscripted conversations with game characters. And get this, there's a startup called OvoMind that's working on a wristband to read your biofeedback, things like stress or excitement, so the game can adapt to your emotions in real time.
As cool as those things are, they're really just the beginning. So where is all this headed? Let's peek over the horizon at the truly futuristic stuff that's coming next.
A lot of experts think the next huge canvas for gaming AI is going to be augmented reality, or AR. Remember Pokemon Go? It used your phone's location to put virtual creatures into the real world. Now, that was a pretty simple but brilliant first step.
And Julian Toglias puts it perfectly right here. The real magic isn't just plopping a character onto your sidewalk. It's using AI to turn your actual surroundings into game content. Just imagine an AI that scans your living room and turns it into a fantasy dungeon, or transforms the people walking down your street into characters in a spy thriller.
And that idea naturally leads to one of the holy grails of gaming, non-player characters, or NPCs, powered by large language models. We are talking about characters you could have a real, open-ended conversation with, characters who remember you, who have their own unique personalities. It would be a total game changer.
And experts like Toglias are pretty confident this is coming. The technology is almost there. But
There's one massive roadblock, and surprisingly, it has almost nothing to do with programming.
So what's the holdup? It really just boils down to money. There's a huge mismatch in the business model. See, we're all used to paying a one-time fee for a game, right? Maybe $75. But a truly powerful AI, an LLM, needs constant access to enormous, power-hungry data centers for every single player. That $75 price tag just doesn't come close to covering that ongoing cost. It's this big economic puzzle that the industry hasn't figured out how to solve yet.
And that economic challenge, that's just one piece of a much bigger puzzle. Because for all its amazing potential, the rise of AI in gaming comes with some pretty serious downsides and really complex ethical questions. The challenges are pretty significant, and they fall into a few key areas. We're talking about the very real possibility of job displacement for artists and designers, major privacy concerns over how our data is used, those high energy costs we just talked about, and some really thorny copyright battles over AI-generated stuff. Check this out. More than half of all people working in the game industry are already using AI tools. But that wide adoption comes with a whole lot of anxiety. The fear of being replaced isn't just some abstract idea. When you see huge companies like Microsoft lay off thousands of people in their gaming divisions, it makes those concerns feel very, very real. People are worried that AI is going to automate creative jobs right out of existence. And then you've got the whole privacy issue. As Tegelius points out, a game that adapts perfectly to your personality sounds cool, but what if it adapts to your spending habits to subtly manipulate you into buying more stuff in the game? There's a really fine line between a personalized experience and an extremely creepy one.
So in the end, AI is a classic double-edged sword. I mean, on the one hand, it can automate the really grueling, repetitive work like QA testing, playing the same level hundreds of times just to find bugs. But on the other hand, the AI tools that generate art are trained on existing work, which creates massive copyright headaches and threatens the jobs of the very artists whose work it learned from. So, from a fictional computer learning not to play a game of war, all the way to real AI that's learning how to build entire worlds for us to play in, it's pretty clear this technology has come an incredibly long way. It promises games that are more immersive, more personal, and maybe even endlessly replayable. But all that progress forces us to ask some really tough questions about cost, about creativity, and about ethics. And that brings us to the biggest question of all. As AI becomes the architect of our future worlds, who exactly should be writing the rules? Thanks for watching The Explainer.